Alright, today we're going to do the last lesson in this unit, which is using graphs to estimate values. Alright, so for example, let's take a look at this special situation. Keisha gets an allowance, and her allowance is shown in the graph below. To draw the graph, we plot the points and connect the dots. But if we want to find any values between the points that we're given, this is called interpolation. Okay? This is called interpolation. Now, using interpolation, how much Keisha will have after 2.5 weeks? Well, to do a question like this, what we want to do is we want to find 2.5 weeks, which would be like right here, and we want to go up the graph until we hit the line. And once we hit the line, then we're going to go all the way to the left and find that the answer is right here. So we have to figure out what number is here. Well, we see that 2 of these ticks is 40, so that means that 1 tick must be 20, so 20 more than 80 is 100. So the answer is 100. How long will it take Keisha to earn $150? Well, we find $150, and this would be 140 right here. So here it is a bit of a guessing game, but 150 is going to be like right about here. So you're going to go along here until you hit the line, which would be like right here, and then go all the way down, and you're going to get about, now we're estimating here, so it's going to be between 3.5 and 4. So maybe 3.75 weeks. But what if we wanted to find out how long it takes Keisha to earn $320? That value is off the graph. To find it, we need to extend the graph. If you want to find a value that's outside the values graphed, this is called an extrapolation. Okay? So now what we want to do is we want to find when she makes $320. So we're going to find $320, that's right here, and we're going to go all the way across until we hit the line, and then go all the way down, and see that it takes 8 weeks. So it takes 8 weeks. Oopsies. For her to earn $320. Okay? And that's how we do it. So how we would extend the graph is just take a ruler and we just extend the line. So we just line up the ruler along this line here, and then with the straight edge just continue the line as far as we need to. Okay? So Irvin has a 360 day and plays 360 all day. The battery life in his wireless controller is shown in the graph below. So when he starts, it's right here, and when the battery runs out, it's right here. How much battery life is left when Irvin starts playing? Well, what's his value halfway between 60 and 80? Well, that's going to be 70%. So the answer is 70%. After 2 hours of playing, how much battery life is left? 2 hours of playing, go up, and we're halfway between 40 and 60, so that would be 50%. How many hours will it take Irvin to drain the battery life completely? Well, we see the completely is halfway between 6 and 8. So that's going to be 7 hours. Okay? So we're just reading the graph and taking values off of the graph to give an estimate. The title of today's lesson is Using Graphs to Estimate Values. That's what we're doing. We're given an estimate. Another example. Matt becomes a better skater by doing skating drills every weekend. The graph below shows Matt skating. So we've got kilometers skated up here, and we've got time in minutes down here. How long will it take Matt to skate 60 kilometers? Well, we can't do that question without extending the graph. So here's a different version of the same graph, and what we're going to do is we're going to take a ruler and we're going to extend that line. I just have to make my line. Okay, now we're going to extend that line through the graph. So this would be a great opportunity to make sure we all have rulers. Okay, now you can pause this video now so everyone gets rulers, and then continue it when everyone does have rulers. Now that we all have rulers, we're going to draw this line. Mine's a little bit off, but I can fix it in a second here. And you're going to draw it all the way through. Then we're going to let go. Oopsies. And I butchered mine, so I have to try and fix it a wee bit here. I'm happy with that. And then I'm going to take it and I'm going to move it so it goes right over here. Done. Okay, so how long will it take Matt to skate? 60 kilometers. Now what we do is we go across from 60. Now, keeping in mind that this right here is 60 right here, it's halfway between 56 and 64. So I go all the way across until I touch the line, which I do like right here. And I go all the way down, and I get about 76 minutes. So that's how long it takes Matt to skate 60 kilometers. How far will Matt skate in 80 minutes? Well, now we just go up from the 80 minutes. We go up all the way, and we see that it's about 64 kilometers. So 64 kilometers. What assumptions are made? Assumptions are decisions that we make. And in this example here, a good example of an assumption is that we're assuming that Matt will continue to skate at the same rate. He won't slow down, he won't speed up. That's an assumption. That's a decision we're making to predict a future event. We're predicting his future skating, and we're predicting that he's going to skate at the same speed, and he's not going to get tired, or he's not going to suddenly start wanting to skate faster. So he will continue the same speed of skating. Okay, that's the assumption that we make. Okay, so using the graph to the right, what's the value of y when x is 4? Well, x is 4 right here, we go up and we get 6. So the answer is 6. What's the value of x when y is negative 4? Well, we have to extend this graph, and let's go down here more. I'm going to be just a wee bit off again, but that's okay. And now I'm going to find out where y is negative 4, which is of course right here, and I'm going to go all the way across until I get to the line, which is right here, and then go up to see the x value, and the x value is negative 16. So the answer is negative 16. That's the x value when y is negative 4. Alright, so for homework, you have pages 196 to 198, numbers 4 to 14. Graph paper may be useful. It's on the overhead cart. Have fun.